Hello everyone, I'm here to explain about my project, which is a machine learning model. I have built a classification model. My problem statement is smart home energy optimization using IoT. First, we need to understand what is a classification. Classification is a type of machine learning task which sorts data into different classes or groups based on certain features. Now we hope we understand what is a machine classification. First, we need to import four things. The first one is import pandas as PD. I've used that in order to read the CSV dataset. And second one is sklearn.model underscore selection. I have used this because classification is ensemble learning, which means it makes hundreds of decision trees and selects the best one based on the majority vote. And I have imported train test split because machine has to train and test the data set in order to know that the machine has been learned correctly. From sklearn ensemble, I have told before, import a random forest classifier. I have used random forest classifier particularly because it works better than logistic regression, which can also be used for classification, because random forest classifier can learn non-linear data relationship where logistic regression cannot, and it has more other features like it can avoid overfitting, it is robust to noise, etc. From sklearn.metrics, import accuracy score. Accuracy score and confusion metrics is metrics for classification. There are more than two, but I have only used two here. Now in the second thing, you have see that the data have been read and imported here. So it is a CSV, so I have given as read underscore CSV. If it is a Excel, I can give here as pd.read underscore Excel. Print.head. So the head means that it will print like 3 to 5 rows or columns in order to give an overview of what is present inside the data set. As you can see, there is wind speed, visibility, dew point, applications, appliances, etc. And there are also 5 rows and 26 more columns which is not present here. Now, the reason why we call is that classification because it classifies based on certain features. I have given a condition here, threshold is equal to 100, and I have created a new column, high underscore energy. So if the appliances has having threshold more than 100, it would be stored on this column, and has type.int because all these values are in integer. I have given that. Now the independent variable and dependent variable. X is called as the independent variable, Y is called as the dependent variable. A dependent variable is a target variable where the machine can learn and make prediction based on that. X is the independent variable which is other than the dependent variable. Now I have dropped two columns because these two are the dependent variable, appliances and high energy. I have chosen this one as the dependent variable because I have made that based on a condition. Now xtrain xtest, we need to test and train the data in order to know that the data has been learned correctly by the model. So train is used for training and test is used for testing. Train test split, I have told before that the testing we have to train and test the data in order to know that the machine has been learning correctly from the data set I have given. So we have taking the independent variable, we are taking the dependent variable, and the test size as 0.2 because there is a common practice which says 80 to 20%. We can take 80% of data for training and 20% of data for testing. This is not constant, you can change according to your data set. Random state 42. Now random state 42 is that it keeps the data constant without changing the values. Now here is where we create the model. So I have given a name of rf underscore model. As I said before, random forest classifier, n estimators is equal to 100, so it creates hundreds of decision trees. This means it creates hundreds of decision trees. Now random state 42, I have told before, it keeps the value constant. We can also give here 0. rf underscore model dot fit. So we need to fit this model to train and only train. rf underscore model now ypred, we need to make prediction. We can fit the model in training and predict the model in testing to know that the model has been trained correctly. Now ypred is equal to rf dot model, which I have created here, dot predict. We need to predict on testing data. Now I've told you about the accuracy and confusion matrix. Accuracy is that how much the machine has been learned based on the data set I have given. Now here accuracy score, we have to make accuracies on testing data, and the ypred I have made here. Now you can see that there is 90% of data has been correctly, you have given the correct values, so which is not bad. If you want to increase the data, you can move on to feature scaling and make the data set more cleaned. Now confusion matrix is defined as the data where the machine has been learned and made predictions which is correct and which is not correct. As you can see, there is 4 values. The first one is for true negative, and the second one is false positive, and the third one is false negative, and the fourth one is true positive. Now true negative means the data has been predicted that is correctly negative values. Now false positive means the data predicted by the machine which is false, which is incorrect and which predicted as positive. Now false negative, which means that the data that is predicted by the values negative, which is not negative, and it predicted the incorrect negative values. Now true positive is that the data that is predicted by the machine has been correctly predicted as positive. So that's all for now, and hope you understand it better, and thank you.